Welcome to Chibuzor Mathphysics. In this video, I will be taking you through numericals and calculations on the first law of thermodynamics. Stay tuned and enjoy. We've got a question that a foam cup is filled with hot water and allowed to cool while being stirred by a paddle well. Initially, the water has an internal energy of 200 kilojoules, and while cooling it loses about 150 kilojoules of heat. So the paddle well does 25 kilojoules of work on the water. So we are to calculate the change in the internal energy of the water and calculate the final internal energy of the water. In case you are joining us, you can refer to my first video where I talked about the introduction of the first law of thermodynamics. We also discussed the importance of heat transfer, why it is very important to understand that energy can neither be created nor destroyed. We can only transfer energy from one form to another. That would be a prerequisite for us to solve this problem. So let us dive into it. Stay tuned and enjoy. I remain your friend, Augustine Kalagash. So let us take our solution. If you look at the questions that we are given, let us find out the values that is given in the equation. So the given values, we know that the initial energy, because we are to find, the first question said that we need to find to calculate the change in internal energy, which will be represented by U. So U, that is the internal energy, is given to be 200 kilojoules. 200 kilojoules. We have 200 kilojoules, and while cooling it loses about 150 kilojoules. So the work, the paddle well does 25 kilojoules of work. So we have the work on this system will be 25 kilojoules. So let's have the work on the system. The work on the system, W, is equals to 25 kilojoules. So the heat transfer, Q, the heat transfer, let's refer back to the question. The heat transfer, because while cooling it loses about 150 kilojoules. So this will be the heat transfer in the system. So let's have that done. Let's have that done. So the heat transfer is equals to 150 kilojoules. So the first law of thermodynamics here is expressed using the first law of thermodynamics. We are to calculate the change in internal energy, which is expressed to be Q. This will be equals to the change in internal energy plus the work done. So we can see that it is positive Q. So Q here is positive because according to the equation, it shows us that heat is supplied, and that means that it is positive. So W will means that work is done by the system. So work is done by the system, and that is why we are using this positive sign. And just in case you see negative, negative will imply that work is done on the system. But when work is done by the system, it is positive. But if work is done on the system, it will be negative. So as energy is lost, we will use the negative sign for Q as well. So the equation will becomes negative Q will be equals to change in internal energy delta U minus W. Of course, we know that W is work is done on the system. So therefore, delta Q will be given by, let's take a different color. Delta Q will be given by negative Q plus W, negative Q plus W. And this simply means that work is done on the system. Okay, so now we are ready to go to calculate the change in the internal energy of the system. So the change in internal energy of the system, let's take a brighter color. So question A, we are to calculate this, that is the change. So let's write calculating the change in internal energy, which is our question A. We are going to use delta Q is equals to negative Q plus W, implies that work is done on the system. So this will be that we know that 150 is Q, so this will be negative 150 plus 25. 25 is the work done as indicated, so 25. And if you plug this in your calculator, you will simply get negative 125 kilojoules. So the change in the energy of the water will be given by negative 125 kilojoules. So the negative sign means it has lost. So it means it has lost 125 kilojoules. If we calculate the final internal energy, that is UF, if we calculate UF, this will be given by the change, the final minus the initial. Of course, we know that internal energy plus the initial will be equals to, we had negative 125, which we got here, plus 200. This will simply give us 75 kilojoules. 200, as you might notice, is given in the equation. 200, if we record the equation, you find out that 200 is the water has an internal energy of 200 kilojoules and while cooling. So 200 in this case is the initial internal energy. So for us to calculate the final, we just need to take the final minus the initial. So that's why the change in internal energy plus that initial will be given by negative 125, which is the change in internal energy that we got in question A when we calculated the change in internal energy, plus 200, which is the initial internal energy given in the equation, and this will give us 75 kilojoules. And this is how we deal with the equations on calculating the change, the work done. Either maybe the work is done on the system or the work is done by the system. Things to remember, I have said earlier that the change in the internal energy of water, as we got negative 125 kilojoules, the negative sign means that it has lost 125 kilojoules. And it is good to note that we will use the negative sign for work done on the system. When work is done on the system, we use the negative sign. But when work is done by the system, we use the positive sign. See you in our next video. I remain your friend, Galagash.